Hi everyone, I am Gaurav from IIT Kharagpur in India and L3S Research Center in Germany. This talk will be on our paper titled Fair Ranking, a critical review, challenges and future directions. This is a joint work with Lorenzo from Universitat Pompeu Fabra in Spain, Laura from Competition and Markets Authority in UK, Q from Accenture UK, Mike from Zalando and Max Planck Institute, and Nikhil from Cornell Tech US. Today, I, along with my colleagues Q, Lorenzo, and Laura, will be presenting the work. So let us start with the presentation. In the recent past, a large fair ranking research literature has been developed around making fair information retrieval systems. Most of this literature defines fairness for a single instance of retrieval or as a simple additive extension for multiple instances of retrievals over time. We will first give a brief overview of the fair ranking literature. Our view is that prior works on fair ranking risk being ineffective for problems faced in the real world settings due to their narrow scope. We will first discuss some important but ignored aspects as pitfalls of current fair ranking models. Following this, we will also provide a path forward for more holistic and impact oriented fair ranking research agenda. Additionally, to overcome some data and legal bottlenecks, we will also discuss the role of broader stakeholder community. Major online platforms today have a lot of providers who list their items or services on the platform, and the consumers on the other side utilize various information retrieval services like search and recommendation for relevant item discovery. These retrieval services use ranking at their core. Now let us see some examples. On e-commerce platforms, products are listed by various sellers. Similarly, on hiring platforms, job seekers add their profiles, which then get to ranked for the employers. On media streaming platforms, artists provide media content. The question here is that what do these providers gain by getting ranked? They get sales on e-commerce platforms, employment opportunity on hiring platforms, and royalty or ad revenue on media platforms. Now let us see how the rankings are usually done. Let us consider this example with four job seeking candidates. Most of the platforms use some data driven machine learning or statistical methods to estimate relevance scores for each item, that is, each candidate profile in this example. The most popular guiding principle in information retrieval is the probability ranking principle, which says that we should rank the items in descending order of their probability of relevance to optimize for ranking utility. Here, the optimal ranking will be as listed in the table based on the relevance scores. Now, what could be the problem here? Due to the ranking and the existence of position bias, items in the top positions receive more attention than items in the lower positions. Here in this example, if we add up the attention received by the two groups of candidates, namely the circle group and the triangle group, it will be zero point 0.9 and 0.22 respectively. The difference in attention received by the two groups is significantly higher even though they have very similar relevance scores. Therefore, in ranking, the disparity in machine learned relevance scores is not the only problem, but but the presence of position bias significantly increases the scale of any existing disparity. In summary, any unfairness in bringing socioeconomic opportunity to individuals could lead to significant societal harm. Therefore, the common motivation for fairness in rankings has been to ensure fair access to opportunity for the providers. Most of the works in this domain consider the total exposure of a platform as a limited resource and propose mechanisms to ensure equitable allocation of exposure for fair ranking. However, such mechanisms designed mainly focusing on exposure often miss out on various real world nuances, and because of this, such fair ranking models may fail to promote fairness in real world
We have
settings.
summarized them
Next,
into
we
three
discuss
major
some of the
categories:
pitfalls of
delayed
such
impact,
fair ranking models.
ecosystem dynamics, and uncertain outcomes. Delayed impact is the biggest and most prominent category. we would like to point out three aspects of such impact. First of all, as previously explained, exposure is often used as a proxy for provider utility in the fair ranking field. The rationale is often that the ranking position can equate exposure received, user attention assigned to the item, and then ultimately provider utility gained from such item. There are plenty of assumptions and simplifications baked into such logic from various aspects, which we believe should be taken into consideration when designing the ranking mechanism. Secondly, there is often temporal significance assigned to the ranking. In fast-moving domains such as media, items or services may only be relevant for a short period of time. The item and services value degrades as time goes by. For example, if a piece of breaking news is only recommended to users after a month, it will not be very significant even if its ranking after a month is assigned to be at a very high position. What's more, substantial externalities or spillovers coming from the recommendation system itself, complementary recommendation systems, and associated services could also be incorporated into the mechanism design, in addition to the immediate effect of an item's ranking position. Examples include spillover effects from things like complementary recommendations, trending items, or even from other platforms, which can be a much broader and less visible or quantifiable effect. In ecosystem dynamics, we would like to point out that current fair ranking mechanisms often fail to consider that providers themselves could also be strategic players in the system. There are two main types of behaviors from them. Providers can initiate adversarial attacks to game the fair ranking model. For example, attacking the measurement construct gap between exposure and its provider utility as previously mentioned. Or they can also exploit specifically characteristics of fair ranking algorithms with actions such as content duplications. However, strategic behaviors may not always be malicious. It could also present a sincere effort for improvement on content quality or shifting offering focus. Such behavior may still affect the efficacy of fair ranking mechanisms over time. For example, vendors catering to the taste of algorithms instead of the taste of actual users will cause homogenization of platforms' item space and decrease user utility over time. It can also hurt the viability and welfare of small-scale providers. Lastly, we would like to note that platforms can also play a role of providers, which often give them unfair advantage over other providers. The last pitfall is about uncertainties and noises. Fairness-aware ranking mechanisms proposed for exposure and probability-based fairness often assume knowledge of certain sensitive info about the users or providers on which to remain fair and of the value of each position in the ranking. In terms of sensitive data, demographic info is a good example. Most of the time, they're estimated based on a data-driven approach with historical data, which often introduce huge uncertainty and bias and can cause significant harm to vulnerable groups. In terms of ranking position values, we have previously discussed position bias as an example, which greatly affect click-through rate in such context. But such bias is often very uncertain due to factors such as dynamic or even customized user interface. Additionally, all these uncertainties can be differential, meaning they affect some participants more than the others, even within the same protected groups. It may occur in situations such as when platform has more information on one participant over some others. It can create downstream disparate impact. Now we have looked into the major pitfalls seen in current research, and we will then present what we suggest to future fair ranking studies.
There are two broad lessons from the algorithmic impact assessment literature that we apply to the design of fair systems in a manner that involves integrated effort from different actors and a comprehensive view of their effects. A first key point when assessing or auditing algorithmic system is to move beyond discrete moments of decision-making, and this point is particularly true for fairness interventions in ranking and recommender systems, as we have seen before. Second, a key aspect of effective assessment is the participation of every suitable stakeholder, including developers, affected communities, external experts, and public agencies. Otherwise, a danger is that the research community focuses on impact most measurable by its preferred methods and ignores others. Outside of fair ranking, the recommendation literature has investigated such long-term and indirect effects using simulation and applied modeling methods. Indeed, simulation-based environments can help in first, studying various relationships between the usage of systems and individual and collective behaviors and effects. Second, detecting new forms of relationship. For instance, the fact that the user's high reliance on recommendation might lead to lower accuracy and discovery. Third, replicating results obtained in empirical studies, as for the case of popularity bias in search engines. Given the usefulness of simulation, many frameworks have been developed, and here we have listed a few of the most recent ones. Note, however, that the simulated environments are created under certain assumptions on the interaction between the stakeholders and the system, which may not always hold in the real world. Therefore, is it important to question how different values and assumptions might be influential on the simulated environments, and which worldviews have been modeled while developing such frameworks. On a positive note, simulation can be designed to be flexible enough, and we believe that leveraging such simulation frameworks is an important path forward to studying the various effects discussed. Second, various temporal, behavioral, and causal models have been traditionally been used to formally study complex dynamical systems in fields like social networks, game theory, or economics, for example. These models often rely on real-world observation of individual behavior, extract broader insights, and then try to formally represent both individual and system dynamics. Suitable applied models can be integrated within the simulation to ensure that ecosystem parameterization, stakeholder behavior, and system payoff are representative of the real world. However, these approaches will further benefit from availability of certain data and the resolution of related legal bottlenecks, issues on which now we will continue discussing.
I'm going to summarize some data and legal aspects. For datasets, consideration needs to be given to which datasets may be suitable for long-term fairness analysis, how these datasets might be used, and what complementary information could help with the analysis. For example, by complementing the datasets with additional contextual information to understand the broader environment and underlying dynamics in which the ranking operates. This could be, for example, whether users can also be directed to products through affiliate links, or relevant interface design characteristics that feed into the prominence of products on the platform. In terms of the analysis of data, it would be useful to move from static to temporal analysis, for example, monitoring the effects of previous rankings over time or temporal variations in the rankings, and also incorporating modeling of uncertainty, for example, uncertainty over the genuineness of reviews that feed into rankings, or the uncertainty around labels describing individual or product characteristics. In terms of legal bottlenecks, there is an information asymmetry between platforms implementing rankings and therefore holding ranking data and the researchers and individuals who may want to analyze this data. Laws can enable access to ranking algorithm information and also underlying data, for example, the individuals or products to which the ranking algorithm is applied. However, there can be differences in laws across jurisdictions, which can restrict data access for different stakeholders. For example, EU data privacy law may restrict dataset access to researchers outside of the EU. In addition, some legal guidance acknowledges that there should be consideration given to the privacy-transparency trade-off, whereby a platform may not want to reveal too much detail about their ranking algorithms due to concern that bad actors may be able to use that information to game the ranking system. Some existing laws not specifically targeted at long-term fairness in ranking can be applied to this field. However, consideration needs to be given as to how different parties, for example, a platform itself versus a regulator, may interpret their responsibility under these laws, given that legal precedents have not yet been built up in this area. In addition, some laws, such as those covering discrimination, may be more appropriately applied to the ranking of individuals versus products. To conclude, we've provided a critique of instant-based static fairness evaluations. We want to move towards evaluations which model more effectively the impact and interactions of ranking systems in real-world environments. This long-term fairness assessment should incorporate contextual information and consider ecosystem dynamics such as strategic user and platform behavior, temporal variations, spillover effects, delayed impact, and uncertainties. While acknowledging that there are technical, legal, and other limitations in being able to fully evaluate in this way, we have outlined ways in which data and methods can be used to move towards long-term fairness evaluation. For example, through simulations and causal and behavioral modeling. Some future directions for research include how long-term fairness assessments apply in two-sided marketplaces, and also how long-term fairness definitions and frameworks should apply to individuals versus products. Thank you for listening.